They heat the samples to 2,000 degrees Fahrenheit for about an hour to burn off the impurities. What's left after the burn-off are the silver and other metals, such as lead, zinc, copper, selenium, and cadmium. Lab technicians then treat the samples with a chemical that prevents silver from burning off and put them back in the oven. When the samples come out, about an hour later, all the other metals have burned off and only silver is left. They weigh the silver and compare it to the weight of the original sample in order to calculate the grade. The key to running a profitable mine is to ensure that the grade is consistently within certain parameters. Back at the mill, workers put the now dried silver precipitate into an oven, along with chemicals which prevent silver from burning off. Approximately 4 hours later, the silver and waste have separated and melted. Workers pour them into bar-shaped molds. The silver, being heavier, settles at the bottom. Workers skim off the waste floating on top. In less than 5 minutes, the molten silver cools and hardens, enabling workers to extract what is now a silver bar. The mining company sells the bars to a refinery for processing into industrial-grade silver. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/how it's made. Today on How It's Made, technical class. Washing machines. Playing cards. And crossbows. A traffic intersection, a Hollywood movie set, the outside of an airplane. It's hard to imagine any common ground among them until you flip a switch, a light switch. Traffic lights, movie lights, and aircraft lights are all made of the same type of special glass. It's called technical glass. Borosilicate glass has a low thermal expansion and is very durable. It's used in high-temperature applications and when abrasion resistance is important. It begins with a mix of silica sand and chemicals called batch. Workers shovel the batch and recycled glass called cullet into a pot furnace where they melt for 2 days. A variety of colorants are added to make hundreds of different colors. Next it's on to the molding process. Workers heat a ring and transfer it to the top of a mold. Then they twist and turn a stick called a punty to gather some melted glass and carefully string it in the mold. A plunger squeezes the molten gob into shape. The glass solidifies in seconds. This glass lens is used as the landing light cover on an aircraft. They extract it from the mold for a quick inspection, any imperfections, and it gets recycled. If the lens is acceptable, it's held in a forming device to finalize the shape. Maintains the proper temperature of the ring. Once formed, the lenses are cooled in an annealing oven, which relieves unwanted stress in the glass. This circular mold makes theatrical and landscape lighting. Again, a gob of molten glass is dropped in the mold, and the plunger is depressed, forming the lens. Heat-resistant tongs enable workers to handle the hot lenses. Red and yellow lenses need a high-temperature anneal for the color to appear. This is called striking. Back on the molding line, special tools are used to ensure this aircraft lens maintains its shape. A quick spin on the light wheel illuminates any defects. After a trip through the annealing layer, the lenses are ready for further processing. The molding process for larger lenses can be more complicated. This large convex lens requires several gobs of molten glass, placed carefully on top of one another. The plunger enters into the molten glass, forming the lens. Deep ridges located in the plunger of the mold create the circular prisms on the glass lens. Within seconds, the lens is ready for extraction and inspection. Using heat-resistant nits, workers scrutinize the glass from every angle, checking for small fractures or imperfections in the glass. Next, they inspect for flatness using a paper-thin plastic feeler. If it slides underneath, the lens is warped and unacceptable. They check the glass thickness in many locations using a calibrated thickness gauge. Any major defects, and they discard the lens. In the factory's finishing shop, they use a diamond saw to slice away excess glass around the periphery. A special sanding belt is used to smooth the surface to perfection. Then, with a cloth buffing wheel, they polish the glass to a shine. At last, the final inspection. Using calipers, they measure the lens's ridged edge, called the flange, to make sure the dimensions are correct. Producing such a colorful assortment of technical glass takes a lot of work, but at least there's light at the end of the tunnel.
People have doubts about taking aspirin for pain, but they haven't experienced extra-strength Bayer advanced aspirin. In fact, in a recent survey, 95% of people who tried it agreed that it relieved their headache fast. Visit FastReliefChallenge.com today for a special trial offer.
Nature is spectacular. A million Americans. See for yourself at T-Mobile.com.
It's so important to make someone happy. Make just one someone happy. And you will be happy too.
If you're a woman and you're sick and tired of watching your hair get thinner and thinner, we're about to challenge everything you think you know about hair loss. Because we're going to send you a risk-free trial of a product that fights women's hair loss. It contains the only FDA-approved hair loss and regrow thicker, fuller hair. Keranique is also sulfate-free, so it's gentle for color-treated hair. Ladies, it's finally your turn to be free from the embarrassment of hair loss. Call 1-800-541-4764 in the next 5 minutes. Try Keranique before you buy it. But hurry, supplies are extremely limited. For your risk-free trial, call 1-800-541-4764. That's 1-800-541-4764.
Strip this city. We strip this city down to rock and stone. Strip this city. We stripped this city down to the bone.
Tuesday, science hints that greatest cities in the world to hidden engineering secrets. Strip the City. The 6-part series premieres Tuesday at 9 on Science.
In the days before electricity, doing laundry was just plain hard work. The first electric washing machines were little more than a bucket with a motor attached. Fully automatic machines came about in the 1960s. But with rising concern for the environment, there are new designs that need less water and electricity to get the dirty job done.